Okay, this is question 4.5 in Klein's second edition organic chemistry textbook. Basically, they want us to identify and name the substituents on each of these organic molecules. Now, these are alkanes. We know this because there's no double bonds or triple bonds or any other interesting functional groups. But before we start doing that, we need to first rule out the parent chain. So we're going to, identify the parent chain here. I highlight it with red here. Okay. And remember again, your parent chain is going to have the longest continuous link of carbons or the longest continuous ring of carbon atoms. So we've got one group here, one group here, one group here, one group here, one group here. And these are all methyl groups. One carbon substituents containing one carbon are all called methyl. Okay, so those are called methyl groups. So that's how I would name all of those. Let's look at B. We want to go through this molecule and we want to select the most number of substituents. Okay, so remember that you want to select this one with the most number of substituents. And there's a rule for that. When you can select two different chains, parent chains, you want to select the one that allows you to have more substituents. So check what you've selected, and maybe I have something different because I have two substituents over here. And then I have the ones that you most likely would select. So this is a methyl group. One carbon is a methyl group. Two carbons is an ethyl group. Ethyl. Methyl. Okay. Part C. The longest chain is going to be right here. And as I've been discussing some of my other videos, you don't want to select any of the carbons that are highlighted red, only the side chains. So we have a methyl group, we have an ethyl group. Okay. This last molecule, you might be tempted to think there's two carbons here. Two carbons is ethyl, but this is just one carbon as a side group, and this is another one carbon side group. So these are two methyl groups, separate, not bonded directly to each other. All right, let's look at this one here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 9 carbons is more than 8 carbons. So we want to make sure that we select the longest chain that zigzags back on itself. And in a blue ink here, we will highlight the substituents, and then I'll name them. So one carbon is methyl, and if you refer to table 4.2, you'll see that this 3-carbon side chain is called prop, and we always add the YL to indicate that it's a side chain attached, or it's a substituent attached to the parent chain. Now, for this one, be careful. You have 4 carbons in the ring, or you have 5 carbons in the chain. So 5 outrules 4. So we want to select our longest chain to be this guy here. And in blue ink here, I will highlight the substituent. And we are not circling this carbon here because that carbon is part of the longest chain. We only have 4 carbons in the ring. So this is a cyclo. Remember, we use the prefix cyclo for rings. This is a cyclo, bute for 4, and then we add YL to indicate it's a substituent attached to something. Okay, so cyclo means ring, bute means 4, and YL means it's attached or it's a substituent. Substituent. All right, this next one looks pretty complicated. I think that's the longest chain that has the most number of substituents. So in blue pen here, I will highlight those. 2, 1, 1, 2. So this is a methyl group. This is a propyl group. I'm sorry, did I just say propyl group? Let me Ethyl group is 2. Ethyl group is 2. Methyl group is 1. And methyl group is 1. Okay? So that's how you do problem 4-5. You just got to be familiar with highlighting longest chains, circling side groups, and using table 4-2. Just need to memorize table 4-2. Thanks for